Absolute minimum. So to find the absolute minimum of anything, we want to look at the endpoints, we want to look at the critical points. So I listed my endpoints over here. I took the derivative over here, solved it, set it equal to 0, set up my endpoint, or set up my critical points, and then I get a list of these are my two endpoints, these are my two critical points. I want to plug everything back into the original equation, see which one comes out with the highest y value, which one comes out with the lowest y value, and then I want to report the x value as the answer. So if I plug in -2, I'm going to get 32 plus 24 is 56, minus 5, so this will be 51. If I plug in 3, I'm going to get -4 times 27, plus 6 times 9, minus 5, so I get -59. If I plug in 0, I get -5. If I plug in -1, it's going to be 4 plus 6 is 10. Let's see. Minus 5 is 5. I want to know the absolute minimum value. So the lowest it ever gets is here. And that happens at an x value of 3. So what you want to report for your answer is x equals 3. Second one, same idea, except I want the absolute max, but I have a closed interval, find my critical points, and check everything. So I'm going to check -2, I'm going to check 4, I'm also going to see if there's critical points. So the derivative is 3x squared minus 6x, if I set that equal to 0. Factor out of 3x, I'll get x equals 0, and I'll get x equals 2, so that gives me 2 more points I need to check, and I'm checking these in the original. So I plug -2 in the original, I get -8. Let's see, minus 12 plus 12, so I'll get -8. If I plug in 4, I'll get 64 minus 48, which is 16, plus 12 is 28. If I plug in 0, I get 12. And then if I plug in 2, I get 8 minus 12 plus 12, so I'll get 8 here also. They want the absolute maximum value, and this time they're saying what is the absolute maximum value. So the absolute maximum value, that's the y value. So what you're going to report to me here is 28. Or if you had just like circled that point, I can handle that. Alright, number 3. What is the velocity when the acceleration is 0? Okay, so I've got my position here. We've talked about, like, let's just make a list of all of them right now. So there's my velocity function, and my acceleration function would be the derivative of that. So when is the acceleration 0? Well, the acceleration is going to be 0 at t equals 1. And then what it's asking is what's the velocity at that time. So I'm going to take t equals 1, plug it in to the velocity function. I'll get -3 plus, so I'll get 3. And they don't give me a label or anything, but it'll be meters per second or feet per second or miles per hour or something per something, basically. All right, number 4. Okay, I'm going to need a separate sheet here, but I've got base of a square pyramid, and they give me the formula. So I'm just going to take the derivative of that and plug everything in. If I get to a situation where I'm stuck, I'll come back and figure out what to do, but I don't think that's going to happen. Remember that when you're taking the derivative here, it is a product rule. I would kind of look at it like that, where that's your first part and that's your second part. And start taking the derivative. So dv dt equals the second thing times the derivative of the first thing, which would be 2/3 b to the first times db over dt, plus the first thing times the derivative of the second thing. And let's see what we know here. So they're asking for the rate of change of the volume, so they're asking for dv over dt. The height is 9. The base is 3. dB dt, so the side of the base is increasing at 6. the base is 3 again. dH dt, the height is decreasing at a rate of 1, so -1. And then it's going to work all those out. So those will cancel. This will give me 18 times 6, so this is 108. Plus 1/3 times -3, so -1. So I get 107. And that would be in meters cubed per minute. Wait, this is supposed to be squared, which means that's -3. That's 105. That's what we're looking for, is 105. All right. Number 5, I think I can fit this one on here. So I got the radius of a circle. Radius of a circle, what does rate of change? The area of the circle. So I'm just going to start with area equals pi r squared, take the derivative and see where we get. So dA over dt equals 2 pi r times dr over dt. They're asking for dA over dt, so I can just leave that there. 2 pi, well, the radius is 8, and dr dt is 3, so that's going to give me 48 pi for an answer. All right, number 6. Let me grab a separate sheet here. All right, person stands 15 meters east of an intersection. So there's a person over here. There's an intersection here. And this distance, which I'm going to call x, equals 15. There's a car driving towards the intersection from the north at 1 meter per second. Well, if this is y, that actually means y is getting smaller. So dy over dt equals -1. Y equals 8 meters from the intersection, which means I've got a right triangle here. Dx dt is 0, because this person and this intersection, the distance between those two things is not changing. And then I've got z to worry about, and dz dt is actually what I'm looking for. So I'm looking for the distance from the car, I guess the car's up there, to the person, like how much is changing. So first I got to find z, which is just Pythagorean theorem. So z is 17. And then if I go x squared plus y squared equals z squared, 2x times dx dt plus 2y times dy dt equals 2z times dz dt. So x is 15, dx dt is 0, y is 8, dy dt is -1, z is 17, and I'm looking for dz over dt. That goes away. I'm going to get -16 over 34. This would be in meters per second equals dz over dt. And then I wouldn't reduce it. You can, but I would just leave it like it is, because if you reduce it and screw it up, you're going to lose points. All right, number 7. So we got this smartphone thing again, where we want to maximize the profit. Well, the profit is basically in minus out. So that is going to equal, so your income is the price of each smartphone times the number of smartphones minus, and then the amount you're spending is going to be $80 times each smartphone. And then the $5,000 is not per smartphone, that's just straight up minus 5,000. So if I distribute here, this will give me like 150 x minus 0.1 x squared minus 80x minus 5,000, which is really negative 0.1 x squared plus 70x minus 5,000. And that's all equal to profit. My job is to take the derivative of that, so negative 0.2x plus 70. I don't know what profit was, but it was a number. The derivative of that is 0. And then I end up doing 70 divided by 0.2 for my answer, which is 350. All right. Number 8. I'm going to grab a separate sheet here again. Okay, so I've got a 50-inch squared photo. And I've got like a distance around the outside. So this is I'm gonna call this x and this y, and I know xy equals 50. 4-inch border at the top and the bottom. So this distance here is actually y plus 8, because I got 4 there and 4 there. 2-inch border on each side, so this distance is x plus 4, because I've got 2 there and 2 there. And I want to use the least amount of paper possible. So the amount of paper I'm going to use is x plus 4 times y plus 8, and I want that to be minimized so I can use less paper and spend less money. Got 2 variables. I don't want 2 variables, so I'm going to solve one of them. That's what this xy equals 50 is good for, so I can rewrite that as like y equals 50 over x. So then this becomes x plus 4 times 50 over x plus 8 equals min. If I distribute, x times 50 over x is just 50. This would give me 8x. This would give me 200 over x, which I'll write as 200x to the negative first. That'll give me 32. So I get like 82 plus 8x plus 200x to the negative 1 equals min. My job is to minimize that, so I'm going to take the derivative of it. So 82 doesn't mean anything anymore. I get 8 minus 200x to the negative second equals 0. So 8 minus 200 over x squared equals 0. Get a common denominator, so I need to put an x squared there, and I need to put an x squared there, giving me 8x squared minus 200 over x squared equals 0. My job is to set the top and bottom equal to 0. Setting the bottom equal to 0 would give you a piece of paper with like nothing, so that doesn't matter. So set the top equal to 0. So if I add 200 to both sides, divide by 8, and solve that, I get that x equals 5. So now the overall dimensions. So if x equals 5, then this side here is x plus 4, so this side here is 9. And I also know that x times y equals 50, so if x was 5, y has to be 10. 10 plus 8, so this side here is going to be 18. So what you'd want to tell me for your answer is that it was 9 by 18. All right, number 9. So we got this open box problem again. So I'm going to have, so we got a 10 by 16 sheet of paper, but I'm cutting little corners out, and I'm going to call those corners like the distance of the side of that square x. So then the volume of this box, this length is not 16 anymore. This length is 16 minus 2x. This width is not 10 anymore, it's 10 minus 2x, and your height is x, because this is the part that'll fold up. So this is length times width times height. If I work that out, I'm just going to put this there and this there and get rid of that x, and then distribute. So this will be 160x. This will be minus 32x squared. This will be minus 40x squared. This will be plus 4x to the third. Hold on, something seems wrong here. Yeah, this is 20. Okay. So volume is 4x to the third minus 52x squared plus 160x. Now take the derivative. So 12x squared minus 104x plus 160. And then you got to factor this. This was not easy to factor. You can't take a 12 out of everything because 12 does not go into 104. 6 does not go into 104, but 4 does. So if I took a 4 out, this would become 3x squared minus 26x plus 40. And then I've got to try to factor that to make this like reverse FOIL. So if I put a, let's see, if I put a 2 here and a 20 here, this will give me 20, negative 20, this will give me negative 6. So that does work. Solving this would give me x equals 20 over 3. Solving this gives me x over 2. 20 over 3 is bigger, that's like 6 2/3. You could not cut 6 2/3 out twice out of a side that's only 10 units long. So this doesn't matter. X equals 2 is your answer. So you're going to cut 2 squares like 2 by 2 out of each corner. So then that would mean that your length is actually not 16, it's actually 12. This is not 10 anymore, it's 6, and then your height is 2. So your volume is going to be 6 times 12 times 2, which is 144, and that's not even what they're asking. I'm sorry. What size should the squares be? The squares should be 2 by 2. I got a little carried away there. Alright, number 10, now that I've like obliterated that whole thing. This is L'Hopital's rule, so if I plug 1 in here now, I'm going to get 0 over 0. L'Hopital says if that happens, you can take the derivative of the top and the bottom and then try again. So if I take the derivative of the top, I will get 3 times 1 over x. If I take the derivative of the bottom, I will get 1. Now I can plug in 1 and everything's totally fine, and my answer is 3. 11 is the same deal, that's also L'Hopital's. If I plug in 0 now, on top I'll get 1 minus 1, which is 0. On the bottom, sine of 0 is the y value at 0, so that's 0. So I'll get 0 over 0. So, you know, I'm going to use L'Hopital's. I should be writing that up here too. 0 over 0, L'Hopital's. So I'm going to take the derivative of the top and the bottom. So the derivative of the top is e to the 2x times 2. The derivative of the bottom is cosine of 5x times 5. And now if I plug in 0, e to the 0, anything with 0 is 1. 1 times 2 is 2. Cosine of 5x. So now it's the cosine of 0 degrees, which is 1. Then 1 times 5 is 5, and your answer would be 2/5. Alright, number 12. Mean value theorem says slope between endpoints equals derivative at some point in between 0 and 16. So the slope between the endpoints. So if I plug 16 in here to get a y value, the square root of 16 plus 9, that's the square root of 25, that's 5. If I plug 0 in here, the square root of 9 is 3 over 16 minus 0. So the slope between the endpoints is 2 over 16, or 1 over 8. That's got to equal the derivative. So the derivative is 1/2 x plus 9 to the negative 1/2 times the derivative of the inside, which is just 1, so you don't need to worry about it. If I rewrite that, that's 1 over 2 times x plus 9 to the 1/2. I'm going to cross multiply there. So you're going to get 2 times x plus 9 to the 1/2 equals 8, which will give me x plus 9 to the 1/2 equals 4. If I square both those, I'll get x plus 9 equals 16. And then x equals 7. And that's That's what you're looking for. Find the value that satisfies Rolle's theorem. So Rolle's theorem is the exact same thing as the mean value theorem, except the slope is automatically going to be 0, so I don't even have to bother finding it. I'm just going to take my derivative and set it equal to 0. I'll get x equals -4, and then you're done. There's nothing more to it there. And then this last guy, so I want to find, this is the position, moving left, moving right, acceleration, all this stuff. So again, I'm going to make just a list up here. So my velocity is the derivative of that. My acceleration is the derivative of that. Okay, when's it moving left? So I'm going to deal with, if it's moving left, moving right, and even changing direction, those all come from the derivative. So I'm going to take 3t squared minus 8t minus 60. Set it equal to 0. I'm going to have to factor that. So, okay, I'm trying to kind of manipulate it so whatever I put there, when I FOIL it out, I end up with -8t. So if I put 3 times 6 would be 18. This is 10, and I want the 18 to be negative and the 10 to be positive. So when I FOIL these two, I'll get -18t. When I FOIL those two, I'll get positive 10t. -18 plus 10 is -8. So this one gives me t equals -10/3. Doesn't matter. This one gives me t equals 6. All right. So my intervals are from 0 to 6 and 6 to infinity. I'm not worried about negative time. That's why I crossed this out. That's why I start at 0 here. To find out if it's moving right or left, I plug back into the derivative. So if I plug in like 4, I can plug it in here or here. I think it's easier to plug in here because I can just look at it and say, okay, 4 makes this part positive and this part negative, which means here my velocity is negative, so it's moving to the left from 0 to 6. If I plug in like 10, both these pieces become positive, so the velocity is positive from 6 to infinity. That means it changes direction at t equals 6. When is the acceleration equal to 0? Well, that's just taking that acceleration function and setting it equal to 0, and you would get t equals 8/6. All right.